Let's take a look at number 25, reverse nodes in K group. So we're given a linked list, reverse nodes in a linked list K at a time, and return its modified list. K is a positive integer and is less than or equal to the length of the linked list itself. So like if you're given K equals 2, we should return 1, 2, 3, 4, 5, and we should return, not, this is the list, we should return 2, 1, 4, 3, 5. Actually, we've already finished this swap for the case for 2, right? Number 24. I'll attach a link at the screen, and please take a look. It's pretty straightforward. And now we're going to handle the general case for any number of k. So yeah, just we follow the what we did in the case for 2. First, we create a swap function, which is I think it's just node. Okay, this function will swap k k nodes. Starting from node next. Node is not counted. Right? Yeah. Okay, so how should we do it? The first one is we need to check if we need to. Oh wait. It's different. Like if we want to go to 3, 2, 1, we need to change it to 3 for 3. Yeah, 3, 2, 1, and then 4, 5. Doesn't mean. Oh. Mm, in the last solution, we just we just swap these two and then go to here and swap these two. And now we need to reverse a linked list, right? I think I've done a reverse linked before. Like for 1, 2, 3, 4, 5, we need to first check if we can reverse a group. There is a group. If we find the target, and then how should we reverse it? Well, we can do it by recursion and reverse it one by one. Yeah. When we find the start, like say, we swap start from 1, and we're going to swap 2, 3, 4, right? Like this. So we just swap point 1 to 4, and then point 4 to 2, and then move this cursor to 2, and then swap 2 with 3. But how can we get 3? Maybe we can just add a new link. Like when we traverse to the next one, we'll add a parent to the previous node. Like when I traverse go from 1 to 2, I will add to 2's parent to 1, and then 3's parent to 2, and then 4's parent to 3. And when I found that there is enough k, I stop here and just set the start to this the target, and then I will just go backwards and remove all those parents link and go to the next one. If it is not, I'll just go from here and remove the parent. It said only constant extra memory is allowed. I'm not sure whether if I'm able to add extra node. Constant memory is allowed. Yeah, first I can use 2 pointers to get the start and the end, and after that, when I need to reverse it, I actually can do it with constant memory. It said only nodes itself may be changed. The values cannot be changed, so I cannot add parent link. Well, um, okay, the first one is swap, and another one is reverse, right? I think another one is reverse a node. Reverse a node. So when I first say when I did swap, I'll try to find the node, like I need to count. So the count first one is 0. Let k next end. Okay, node next, while n count plus end equals end dot next, while count and count is smaller than k. It will end at k, or n is done. So if there is n, which means the start, the next, say like we start at number 1, k given 3, will end at 4. So I'll say if there is n, and the next equals and next. There's a chance that there's the node is n, right? If node is null, we return. If there is enough k nodes. Okay, now what we need to do is reverse, just get next, and cut it loose. Next is null. And then reverse the list except the head. Yeah, because when we are reversing a linked list, we need to pay attention that we better add a new head node to make it simpler. So we reverse node, and then continue. Swap next, and then we create a new node. Start equals new list node. Start next equals head, and then we swap start, and then we return. Wait a minute, we swap. Oh yeah. We return start next. Now we need to reverse a list. So we are given like 1, 2. This is a start. 2, 2, 3, 4. How can we reverse it? It's pretty straightforward. Like we can say we change it to 2, 3, 2, 4, right? And then we change it to 4, 3, 2. We don't need to find the last element first. We just keep changing the next of node, right? Okay, the first one we get 2. We get 2, and then we find the next one is 3. So we set the nodes next to 3, and the 3 is next to 2. And then we go to, yeah, it's gonna be like this. And then we still keep 2, go to 2, and find 4, and then we change 1s to 4, and change 4, no, sorry. When I find 2, right, find 2, and because it's next to 1, and then we find the next of 3, next of 2 is 3, then we say we change 3's next to 1's next to, and 1 next to 3, 1, 2, 3, and then we go to next one, we find a 4, we set 4's next to 1's next, which is 3, and the change is 1 to 4, next is to 4. So yeah, so we can start writing the code. When we call reverse, the node could not be empty, so we don't need to check the null case. Okay, so okay, we set p equals nodes next. So while is there p, while p is there, swap. Wow, is this swap? No. Okay. Anyway, while p is there, and if there is only 1, we don't need to change, right? So while p and p is next. After we swapping these two, which p will go? P will be go to p next dot p next. We just okay, you set it ahead of time. Next dot next. So p equals next. Okay, so this is the full while loop, and then what we need to do, okay, which is first we will set next one to nodes next. So p next equals node next. Okay, and then which means 3 is next is to 2. And and we need to set 2's next to 4, right? So which means which is p's next equals next, and then we will set 1's next to 3, which is node next equals p next. Well, the order it matters, so we should move to here, which means we first set 3 to connect 3 to 2, and then update to 1 to 3, and set p to next one. So we got this one, and then p will then go to 4, and we'll change it again, right? Wait a minute. There is a mistake. P should not be next, because we are calling set to 4, and then we will try to swap the next one. So p should not be next. Yeah. If that's the case, there's no need to check the p, because p doesn't. We only check p next. So next one is 2. If there is 3, we change it to 1, 2, 3, 2, and the p is still here. So we 4, 4, 2. Okay. And by this we will move the second node of the list to in an iteration way to the last element. So, and then finally we would return node. We don't need to return here. Okay. I think this is just finished. Let's run the code. Oh, it's totally different. God. Huh? We number is k. I think we mistaken that. Because k, because we should count it to 1, or we say smaller than k minus 1. Oh, but still we only reversed the first 2 nodes. The second one isn't working. So the problem here is that after we reverse the node, reverse node, it kind of next is null. I see. Yeah. So actually we are cutting the list. So after we reverse the first one, it doesn't matter. We actually we got 4 3, reverse the 4 3, but they are not connected. I'll say we'll just next combine the next one. So how to say end node extra tail. Yeah, we just name it tail, and we name it tail because this while loop ends at p. There's no p next. We say p next equals tail. It should improve, right? Tail is not defined. Reverse tail. Oh god, it's not tail here. End. Oh no, not. It's next. Wait. And next. Swap. Wait a minute. And next. So we swap next. Swap. Yeah, it will be swap next, but next. It's next. Okay. We got 2, 1, 3, 4, 5. Swap. Ah. Okay, okay. Yeah. Huh. Sorry. Because we're swapping keynote starting from node next. We're defining that next is not. We should set end is the right. But end is removed. Now end will be reversed. So we should say here and new end equals this one, and I swap this. We should return p. Submit. It's accepted. Okay, now let's try to make this code cleaner. The first one is that reversed. It's straightforward. Pretty straightforward. And swap, we just it is a recursion. It is straightforward. The only thing problematic is that we need to add the tail and return the last end. So the thing is that actually we should just return the last. We don't need to set the tail here. You could set it here. This will make the code cleaner, right? The end is less. So new end equals next, and start swapping it. Reverse the nodes and concatenate the new end, right? Yeah, this is pretty straightforward. So now let's calculate the time. So in a swap, we actually will try to traverse all the nodes to get the k, and then we reverse by traversing the node again. So actually, this will be O2n space. We are using only an count or end to calculate to store the reference and create a new start. And here we also use the p to traverse, so they are constant space. Cool. So yeah, we're finished. The lesson. Oh, what? Oh god. Next. The lesson I learned here is that we can actually try to remember how to say we can actually try to remember smaller problems, subproblems, like reversing the nodes, we will try to find the ends, and next thing we will do is reverse. The first one is like we try to find the nodes and then reverse. So actually, there's another question about reversing the linked list. I think it's here, number 206. And yeah, please refer to the video there. See you next time. Bye.